All right, guys, we're on the back side of notes, and number 3 says, which table below represents an exponential relationship, and explain. So we have to remember that on the front, if you can remember, there was a multiplier that we would see in the y's. Multiplier. Okay, multiplier in the y's. And so we're going to go ahead and look in the y's and see if we can figure out if there's a multiplier in these tables. And so let's look at the first one. I see 8 to 4, and so I know that 8 times a half would give you 4, and 4 times a half would give you 2, and 2 times a half, or half of 2, is 1, and 1 times a half is a half. And so sorry, those are my children, if you can hear them screaming in the basement. So we know that this one has a multiplier, and we are multiplying by half. So this, I think, is the correct choice, so we'll have to come back to it. If we look at choice 2, in order to multiply, 0 might be a bad choice, but in order to multiply 1 to get 2, 1 times 2 is 2. However, 2 times 2 is not 3, it's 4. And so this does not seem to have a consistent multiplier. So I don't think it's choice 2. In choice 3, 1 times 4 is 4. However, 4 times 4 is not 9, it's 16. And so since it doesn't have a consistent multiplier here either, it's not choice 3. Choice 4, in order to get from 1 to 8 with a multiplier, you have to multiply by 8. However, 8 times 8 is 64 and not 27. And so the multiplier doesn't work here. And so I'm going to go ahead and say choice 1 is exponential. Okay. All right. So going down, it says, what is needed when graphing functions? It says an appropriate axis are drawn if not already given. Either they could be T-shaped or L-shaped, depending if you only want to graph in quadrant 1. Appropriate scale for graph, balanced axes or offset to incorporate an appropriate scale. A table of values, appropriate amount to show function entirely, okay, just to give enough shape to your graph, and any special features of the functions, shifts, asymptotes, graphed with dashed lines, or highlighted. Okay, so those are some tips when we're graphing we had to be careful with. And number 4 says given the function y equals 2, which that's your y-intercept. 3 is your multiplier or your base raised to the x, and that's how we know it's going to be exponential because x is your exponent. And it says algebraically determine the y-intercept. All right, so every single y-intercept has an x-coordinate of 0. And that's how you end up on the y-axis, having an x-coordinate of 0, not moving any left or right. And so if we go ahead and put in x equals 0 and do some math, then this should come out. Remember, anything to the 0 power is 1, and so 3 to the 0 is 1. And then we will end up with y equals 2 as our y-intercept, which we already knew because right there we learned on the front side that that's your a value and that a is 2 and that a is your y-intercept. They want us to write an equation for the asymptote, but let's go ahead and put this in our calculator so we can graph it. So go to y equals, cleared out, and type in 2 parentheses 3 raised to the x, and we can go to our graph to see what it looks like. And then we're going to go ahead and pick some good values off of it so that we can graph it. And we want to make sure we pick some good values that we can graph, positive and negative values of x's if we can. And there's a couple on there. So let's go ahead and start with our table. And it looks like one of the larger values that I can graph might be able to fit 18 on here. So I'm going to go ahead and see how many rows we have on here. 1, 2, 3, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. So I think we can put 218 on there. So I'm going to start with 218 on the bottom and work my way up my table, and we can fit 1, 6 and 0, 2. Okay. And if you can see the pattern here, the multiplier, okay, to go this way, we're multiplying by a third. Okay. A third of 6 is 2, so you can see the multiplier is working. Okay. And then we go ahead and graph some negatives. So this would be -1. All right. If we take 2 times a third, we would get 2/3, which is why in our table we see 0.6 repeating. Maybe take a -2. If we multiply 2/3 by a third, we would get 2/9. And we could go one more if we wanted to. It's extremely small, right? But -3 would be matched with 2/27. Okay. All right. So again, the multiplier works all the way through. You multiply by a third. Okay. All right. So in order for this to fit on our graph, we want to make it to 18 at the top there. And so we can go ahead and put in our x-axis, drop down low so that we can fit 218 on our graph. Okay. We do have a couple negative numbers that we wanted to fit. However, we're not going very far on the positive side, so we can go ahead and try to go right down the middle. Again, if you have a straight edge, you should use it. I don't on this device. So I'm going to try to make the best lines I can. And that's my y-axis, and this is my x-axis. Okay, I'm going to go ahead and try to graph some of these. So positive 2, 18, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 is right there. Okay, 1, 6, 1, 1, 2, 3, 4, 5, 6, 0, 2, -1 2/3. We had -2 2/9. And remember, guys, you're getting closer and closer to the x-axis, but you're not going to go ahead and touch that x-axis. Remember the sandwich story. I ate half my sandwich. Okay. So nice smooth curve between your points. Mine's a little shaky. I apologize. Mine would normally look a little bit better, but the pen I used to write on my screen is so slippery that it's so hard to get that to look nice. Okay, and there we have it. And so in part B, it's asking us to write an equation of the asymptote. And remember, guys, that the asymptote is the x-axis. That is the line we're getting super duper close to, but we're not going to be able to touch it. Remember that the x-axis is a horizontal line, so think hoi, and think y equals a number. And that number is going to be 0, so y equals 0. Okay. Part C says, does the exponential function increase or decrease? And as you read it from left to right, the graph is going up, and therefore this is increase as our answer, and we have our explanation. As you read from left to right, graph is going up. Okay. And the last part there, determine the end behavior as x approaches negative infinity and x approaches positive infinity. So we'll say as x approaches negative infinity, y approaches. So as x approaches negative infinity, which is over here on the x-axis, we're looking at this end here, and that end is going down. However, it's not going down towards negative infinity. It is approaching the x-axis, so it's approaching 0. Okay, so that's a little bit different. And then we can go ahead and say as x approaches positive infinity, and on the x-axis, positive infinity is down there. Okay, and so we're going to be looking at this end, and that end is going up, 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 up. And so we're going to say y is approaching positive infinity. Okay. All right. So that is the end of our notes. And so we'll do a little bit more graphing on day 7. And I'll see you guys then. All right. Have a good one.